So we're going to take a look at factoring trinomials that are in a quadratic form. Now, I call it a quadratic form problem because if we were to look at the powers, you'll notice that we go 4 and then 2 and then none. So anytime that the powers work where it's a value here that is twice as big as the middle one, so I can cut this in half and then go down to 0, it is in the form of a quadratic. So x squared plus x plus like 1 would be a quadratic or next to the 0. So anytime we have an even first exponent that we can cut in half, see how the 2 goes to 1 on the quadratic, like we go 4 to 2, and then we go to none. So it's even, half as big, and then none, we can factor using the magic x. Anytime we have a trinomial that is in this form, we can go right to the magic x and do our work. And even better, this a value is 1, so we can circumvent the whole factoring by grouping step when we get good at it. But for now, we're going to stick with the grouping so we can see how the powers work. So first thing we want to do is take our a and our c value, and we have 14 and 1, so we're going to do 14 times 1, which is 14. And then on the bottom, we get a negative 9. So you just got to work through your factors of 14 that add to be 9. Remember, if this is positive, both these side numbers have to be the same. Here we need them to be negative. So it's going to be negative 7 and negative 2, which adds to be negative 9. And negative 7 times negative 2 is positive 14. So the job is I'm going to go ahead and do the grouping technique so that way we can see how these powers work. I guess I'll leave that there. So we've got x to the 4th stays the same, and then we make it minus 7x squared minus 2x squared plus 14. So what's different from our quadratics is this middle term in our quadratic would have been a single, a linear degree, a linear piece term, and now this negative 9x squared is breaking up, and it's still tracking that these are both x squareds. So at this grouping level, now that there's 4 terms, I'm going to do factoring by grouping. What's going to happen is I'm going to factor out an x squared here, and I'm going to have a result that's not a quadratic. It's going to be a couple of terms that aren't linear initially. So here we go. Factoring by grouping, I'm going to factor an x squared from both of these because that's what they have in common. So dividing by x squared will get me an x to the 2nd minus 7. And then here we have a negative 2 in common, and I want to force that negative 2 to come out because I need this sign to change here. So negative 2 is my greatest common factor, even though it's technically not in common for them to be negative. I'm going to divide by negative 2 to make my signs work out properly at the next level. So x squared, divide this by negative 2, and that's going to be a minus 7. So doing that successfully produces a common binomial factor, and I now factor that out and get x squared minus 7. Divide that out, x squared minus 7, and I'm going to be left over with an x squared. Divide this by x squared minus 7, and I'm going to get a minus 2. Now, this problem is done. We will have to watch subsequent problems for factoring completely. If these turn out to be square numbers, we would have a difference of squares set up here. Now, what I said earlier was we can circumvent this grouping process now that we've recognized, hey, the factors come out. Check out how the factors came out. These are not linear factors. These are quadratic factors. We could have jumped straight from the magic in the x because the a value is 1 to the factor form where the minus 7 and the minus 2 are the numbers in here. But if it was a quadratic problem, we would have just put an x and an x. And so I caution us because that's what students run and they do. They're like, oh, it's just x minus 7, x minus 2. Well, it was an x to the 4th. So what has to happen is when you factor it in half, in 2 pieces, these divide in half. So this is going to be a squared and a square. So if you get comfortable with that, you can jump from the magic numbers straight to the factored form. Understanding why it worked out that way, of course. And then we'll take a look at another example and keep pushing forward for ones that will require a little more work at the second step of factoring. First thing we want to recognize with this problem is that it's out of order. I want to not be hung up on the fact that that looks quadratic and just go, oh, it's a trinomial. Well, it's x to the fourth is actually a quartic problem. So we're going to rearrange it. So we're going to make this standard form, negative x to the 4, and then plus 9x squared, and then minus 20. So the first thing I'm going to do if I'm factoring completely is go through my steps for factoring victory. The first step is always a GCF. Notice there's a negative sign there. If I ever have a negative a value, I want to factor it out. So I'm going to factor a negative 1 from this whole trinomial, and that's going to change each sign. So divide this by negative 1 will give me a positive x to the fourth. Dividing the 9 by negative 1 will get me a negative 9x to the second. And dividing the negative 20 by negative 1 will get me a positive 20. So that's the first step to completely factoring and to making it work. The magic x will not put up with us leaving a negative a value in front there. So we're going to go ahead and do the magic x now. The magic x multiplies your a times your c and the b value on the bottom. So the a times the c is working with this trinomial in the factored form after pulling out the negative 1. So we have a positive 1 and a positive 20. So that's 20 on top. And then we've got a negative 9 on the bottom. So now we have to figure out what multiplies to be positive 20. So this should be the same sign, but they both have to be negative to make the negative 9. So it's going to be negative, negative, and 5 and 4 should be the numbers we come up with because 5 plus 4 is 9, 5 times 4 is 20. And then what we can do is jump straight. If we recognize that this is to the fourth power, we can jump straight to the factored form rather than do the whole process of grouping. And the factored form is just going to be x minus 5, but it's not an x. It's going to be x to the second power and another x squared minus 4. Now, as I warned on the last problem, we can't just jump in here and be like, that's my answer, because we're waiting for complete factoring, which means we have to double check each thing to see if we can do subsequent factoring. Since these are quadratic factors, we have to look for difference of squares or subsequent processes. In this particular one, the 5 is not a square. It is a difference, but there's not a square there. The 4 is a square, so this actually has a little bit more factoring to go. So x squared minus 4 would have been a previous problem that we've worked on before, recognizing it's the difference of squares. This is x squared, that's 2 squared. So we write x plus 2 times x minus 2. So x squared minus 4 further factors to be x plus 2x minus 2. So you replace that factor of x squared minus 4 with x plus 2x minus 2 for a final answer of negative x squared minus 5. That part stayed. And then the x squared minus 4 just gets directly replaced with x plus 2 times x minus 2 for my fully, completely factored polynomial. So in this example, what we're going to see is, although the problem says it's a quartic trinomial, it's actually quintic. Well, really the direction isn't so much about the fact that it's quartic or what. It's more about the fact that we're supposed to be factoring completely. So when we're factoring completely, we want to run through our steps, the 4 steps of factoring victory. And our first step is always GCF. And then we start working our way down to terms, and then we're working our X grouping here because we have 3 terms. So we're just working about GCF and then X grouping. And of course, the other 2 steps, there's some difference of cubes for 2 terms, and then 4 terms is just straight grouping. So we're not playing with those right now. So let's just focus on this one. But first thing I want to recognize is this is not in standard form. So first step, rewrite it to be in standard form. So I got x to the 5th minus 7x to the 3rd, and then plus 6x. And then what we have is a GCF of x. So the first thing we want to do is to kind of make it back into this quartic problem that we thought it was going to be by factoring out an x. And if you factor out an x, all of these will reduce 1 power. So divide this by x. Now I got a quartic, x to the 4th minus, and then divide this by x, and this will be 7x squared. And then divide this one by x, and that'll be plus 6. Now we've got a quadratic form problem trinomial in here that I can use the magic X for, where I multiply the 1 times the 6 on top, and the -7 goes on the bottom. And then I figure out what multiplies b6 and adds b7. The only way to do that is to work with the 6 and 1 to get bigger, to go down to the bottom. And both of them have to be negative so that it multiplies to be positive, adds to be negative. Because there's an a value of 1, we don't have to go through the whole grouping technique. We can just jump down here and make sure we divide this power by 2 to make it x squared minus 6, and then x squared minus 1. Now, the x that was out in front needs to tag along. And then, but wait, there's more. This is x squared minus 1. So you've got to always look at your factors. Don't just jump to the box and say, I'm done. I've got to check my factors and say, oh, that's a difference of squares. This one is not, because that's a 6, but a 1 is a square. So this further factors one more layer to be x plus 1 times x minus 1. And then all the other factors I had in front of it need to tag along and be in front of there. So the final answer, factored form, should be x times x squared minus 6 times x plus 1 times x minus 1. So that's a quadratic form problem after a GCF, so that we can practice our factor completely. Multiple layers of factoring. And we got to cycle back through our 4 steps. Notice right here at the very end, we had another difference of squares. And we always look, when we have 2 terms, for difference of squares or sum and difference of cubes.